And the crazy part is, Airbnb has over 7 million listings globally. 7 million! Imagine trying to find the right one without some serious tech under the hood.
7 million. Whew, that's a lot of vacation rentals to sift through. So we're talking about how they actually make that search feel personalized, right? Not just a random list of houses.
Exactly. Think about it. If Airbnb just showed you listings based on location and price, you'd miss out on so many hidden gems. The real magic is in finding places that match your vibe, your unspoken preferences. And that's where embeddings come in.
Okay, embeddings. We hear that term a lot in the AI ML space. But let's get specific. What happens if Airbnb doesn't use embeddings effectively? What's the cost of getting it wrong?
Imagine you're planning a romantic getaway. You search for a cozy cabin with a fireplace. Without embeddings, Airbnb might just show you any cabin with a fireplace, even if it's next to a noisy highway and decorated with taxidermied squirrels. Your romantic weekend is ruined. The cost? A frustrated customer, a bad review, and maybe even a switch to a competitor. In their world, it's lost bookings, damaged brand reputation, and ultimately lost revenue.
Right. So it's not just about surfacing any listing, it's about surfacing the right listing for the right person. So let's dive into the tech. How exactly do embeddings help Airbnb understand the relationship between properties and user preferences?
Okay, think of embeddings as a way to translate real-world things like listings and users into numerical vectors. Each number in the vector represents a different feature or characteristic. The closer two vectors are in this embedding space, the more similar the corresponding listings or users are.
So a listing with a vector 0.2, 0.8, 0.1, 0.5 might be close to another listing with 0.1, 0.7, 0.2, 0.6. But what do those numbers mean? How does Airbnb decide what features to encode?
That's the million-dollar question. They use a combination of techniques. First, they analyze the listing descriptions, titles, and tags using natural language processing. Think of it like this. NLP helps the computer read the text and understand the key themes. For example, if a listing description frequently mentions mountain views, hiking trails, and peaceful, the NLP model will recognize those as important features. Then, they use machine learning to train a model that maps these features to numerical values in the embedding vector.
Okay, so NLP extracts features from the text, but what about visual features? Airbnb has tons of photos for each listing.
Good point. They absolutely use computer vision to analyze the images. The model can identify things like the style of furniture, the amount of natural light, the presence of a pool or garden, and even the overall aesthetic appeal. These visual features are then also encoded into the embedding vector.
So text and images are combined. What about user behavior? Surely what I click on and book tells Airbnb a lot about my preferences.
You nailed it. User behavior is a huge factor. Airbnb tracks everything: which listings you view, which ones you save to your wish list, which ones you book, and even the reviews you leave. This data is used to create user embeddings that represent your individual tastes.
So if I consistently book modern apartments with balconies, my embedding will reflect that?
Exactly. Your embedding will be close to the embeddings of other users who book similar properties, and it will also be close to the embeddings of the properties themselves. It's like creating a giant network of interconnected preferences. Amazon uses a similar approach for its product recommendations, analyzing your purchase history and browsing behavior to suggest items you might like.
Okay, I see how Airbnb creates these embeddings, but how do they actually use them to surface similar listings? What's the process?
The core idea is to calculate the distance between the embedding of the current listing and the embeddings of all other listings. The listings with the shortest distances are considered the most similar. They use techniques like cosine similarity or Euclidean distance to measure this distance.
Cosine similarity. That sounds like high school trigonometry.
It is, but the intuition is simple. It measures the angle between two vectors. The smaller the angle, the more similar the vectors are. So, Airbnb calculates the cosine similarity between the current listing's embedding and all other listings' embeddings, and then ranks them accordingly.
Okay, that makes sense. But what about scalability? Calculating the distance between one listing and 7 million others sounds computationally expensive.
That's where approximate nearest neighbor search comes in. ANN algorithms allow Airbnb to quickly find the most similar listings without having to compare the current listing to every single other listing. They use techniques like locally sensitive hashing, or LSH, to group similar listings together, making the search much faster.
So LSH is like creating buckets of similar listings and then only searching within those buckets?
Precisely. It's a clever way to trade off a bit of accuracy for a huge gain in speed. Uber uses similar techniques to quickly find nearby drivers when you request a ride. They can't afford to search through every single driver in the city. They need to find the closest ones fast.
So we have NLP for text, computer vision for images, user behavior tracking, embedding generation, and ANN search for scalability. That's a lot of moving parts.
It is. And here's where it gets interesting. Most engineers think that the key to better recommendations is simply building a more complex model or adding more features, but that's not always the case. Sometimes the biggest gains come from focusing on the quality of the data used to train the model.
You mean garbage in, garbage out?
Exactly. If the listing descriptions are poorly written, the images are low quality, or the user behavior data is noisy, even the most sophisticated model will struggle to generate accurate embeddings.
So Airbnb needs to invest in data cleaning and data quality monitoring.
Absolutely. They need to ensure that the data they're feeding into the model is accurate, complete, and consistent. This might involve things like automatically correcting typos in listing descriptions, filtering out low-quality images, and identifying and removing bot accounts that are artificially inflating user engagement metrics.
That makes sense. It's easy to get caught up in the complexity of the model and forget about the importance of the underlying data.
Think of it like building a house. You can have the most beautiful blueprints and the most skilled builders, but if you're using shoddy materials, the house will eventually crumble. Similarly, you can have the most advanced machine learning algorithms, but if you're using bad data, your recommendations will be subpar. Netflix invests heavily in understanding viewing habits, but if their data pipeline is compromised, their famous recommendation engine goes haywire.
So, what are the practical takeaways for software engineers listening to this deep dive into Airbnb's embedding techniques? What should they be doing differently after hearing this deep dive into Airbnb's embedding techniques?
First, don't underestimate the power of embeddings. They're a versatile tool that can be used for a wide range of problems, from recommendation systems to search engines to fraud detection. Think of embeddings as a universal language for representing relationships between different entities.
Okay, so embrace embeddings. What else?
Second, focus on data quality. Before you even start thinking about building a fancy model, make sure you have a clean and reliable data set. Invest in data cleaning, data validation, and data monitoring. Remember the house analogy? Good data is the foundation of a successful recommendation system.
Data quality is key. And the third takeaway?
Third, start small and iterate. Don't try to build the perfect recommendation system overnight. Begin with a simple model and gradually add complexity as you learn more about your data and your users. Think of it like climbing a mountain. You don't start at the summit, you take it one step at a time. Google started with a simple text-based search algorithm and gradually added more sophisticated features over time.
So, to recap, embrace embeddings, focus on data quality, and start small. Solid advice.
Exactly. And remember, the goal is to create a seamless and personalized user experience. By leveraging embeddings and focusing on data quality, you can help your users find exactly what they're looking for, whether it's the perfect vacation rental or the perfect product.
I think the key takeaway here is that embeddings aren't just about algorithms. They're about understanding the relationships that drive user behavior.